the way. Okay, I'll tell you that this is a wrong approach. Okay, wrong or different, hard to say. Okay, for me, okay, I don't want to discredit the book. Okay, it's a different approach. What approach is it? I have not a clue. I'm going to teach you what you have learned. I'm going to apply exactly what you have learned before. So some students send me an email, Eugene. If I were to go back to example number, there was 1 week, we have a very similar example. Yeah, right. So students start referring to this example. Okay, nothing wrong with that. Okay, so if we look at this example over here, right? If we look at this example over here, okay, it is very similar, yes or no? If you look at left and right, it is so similar, man. Okay, it's so similar, right? It's so similar, right? So for this case, we took Vy from the top, right? The area we consider was this area, am I right? Okay. The member will distribute the load, the bolts or the fastener will transmit the load. So it will distribute within that member first. Okay. So for this case, if we were to apply exactly what I've taught you, right? The first moment of area taken should be this area over here. Okay? Right? It has to be that area, or not. Why sometimes we take the web, why sometimes we take the flange. Okay? The approach I'm teaching you guys is generic. Generic means what? It can apply to any situation. I cannot teach you the approach that's unique. Sometime like that, sometime not like that. Okay? Then you tell me, Eugene, sometime I should get a 10, sometime I should get a 20. Yes or no? No. Okay, there is a definite answer. So we're going to apply the same approach now. We're going to take the first moment of area in the shaded region. But for this case, we are going to break one rule. Okay, I'll tell you guys what is the rule. So the first moment of area is equal to Q width multiplied by depth multiplied by y bar. Okay. So this is our, if I were to draw a transformation, yes, Q will go across the centroid. That's the rule that I'm going to break. And I'll tell you why. Does Jihan ask, are we going to break a rule? I say yes. Okay. So the width will be 100. It will be 10, sorry. The depth will be 4. The y bar, right? So we are taking from the top. The y bar, right, from the top, from here to here, is equal to 3.5 because the whole thing is there. So it's 3.5 minus by 4 divided by 2. Okay. Now, if you look at the figure, I'm going to zoom in the figure. Over here, this is our centroid. Absolutely right. Okay. We have to break the rule where we say what? The first moment of area cannot cross the centroid. Yes or no? Why do we have to break the rule? Anyone? This is because we need to calculate the member that distribute the what? The shear force. Right? I repeat again, we have to calculate, determine the member to distribute the shear stress. Okay? And this case is different because they are all what? Members, not one what? solid piece. Okay, if it's a solid piece, I don't know yet. I will not make any statement until I come to a real life example. Okay. So from here, okay. Yes, for the full member. So the question asked by Jihan, so in the case of longitudinal shear, we must always calculate Q for the full member. And that is correct. Okay, always calculate for the full member. Okay. So for this case, you'll get equal to 3.5 minus 2 times 4 times 10. So it's equal to 60 inches cubed. And then when we get 60, we realize that our answer is not the same. Okay? Our answer is not the same as the book. The book says 30, but we get what? 60. Don't panic. Move on. Okay? So the next thing we're going to calculate is the shear flow, Q. Right? So Q is equal to Vy. Let me zoom out. Okay, so Vy multiplied by Q divided by Izz. Okay, let me put the Z down here. Then this is equal to 2, okay, multiplied by the resistance of the fastener divided by the spacing. Okay. Why 2 over here? Because if you consider the center, right, you have one joint over here and the other joint over here. Or some of you might say, Eugene, this is equivalent to one side have Q, the other side is our shear flow. That's why I multiply by 2. You can also say that. It's also valid. Okay. So from here, you have Vy is equal to, what is Vy? 25 or 2.5 times 10 to the power 3 multiplied by 60 divided by Izz. So I'm going to use the Izz given by the book. 566.67. So this is equal to twice Fs divided by spacing. So the spacing is 6 inches. So Fs is equal to 2.5 power 3 times 60 times 6 divided by 566.67 divided by 2. 794.11 power force. So you see the 0 point, yeah, it's the same. Okay. Then you find the stresses on the bolt. Okay. So you can see, right, what we did in the example that we learned is valid. Okay. So it's different from the book. I'm fine with that. Being different is fine. Okay. But I want you to have the confidence, because some of you will ask me, Eugene, why this example you don't consider this one, right? I don't want you to be confused at all. Okay, because our analysis, okay, always starts from the what? The terminal. Right? That's a box beam terminal. Okay? That is the only reason. I hope I clear a lot of confusion. Okay? Not confusion, but confusion. Okay? Right. So this is one question where I had a lot of emails asking me why. Okay. Any questions so far online and Facebook? I hope this is clear for you all. Okay. I want you to have the confidence. More important is the confidence. Okay. This term test, you have to have the confidence and you have to practice your homework question. The questions are going to be from the homework. Okay. Wednesday, I'll let you know how many questions there are. Yeah. I've not set the term test yet, by the way. Right. Then the next question is this one. Okay. So this question looks confusing, but it's not. It looks like, oh, here we go again, right? Right? You look at it, it's not. Right. So I'm going to, I think, number 8. Come on, give me a minute. Let me paste a better image, okay? Okay. So I'm glad. Come on, Eugene. Oh, come on. Don't waste time. Okay. So I'm glad I taught you all how to construct the shear flow first. I repeat again. I'm glad I taught you all how to construct the shear flow. So what is this beam similar to? Which homework package will be the test? Julia, the homework will be from homework. I think homework 5, 6, and 8, Julia. Okay, the term test will be on homework 5, 6, and 8. So if we have our shear flow coming down from the shear stress coming from the top, okay, so I'm going to call this our Vy, right? Then we are going to construct our shear flow. Okay, now this is where things get interesting, right? So the shear flow, so this is a what? Agree or disagree? Right? This is a white flange, right? So white flange, all our terminals are here, okay? 1, 2, 3, 4. Then we construct our what? Our shear flow, okay? Stop writing, see how I construct the shear flow. So the shear flow comes to here, come down here, right? Same thing comes to here, come down here. Then what happened? The fastener will then transmit the what? The load, yes or no? So when the fastener transmit the load, then over here, over there, you feel the shear flow, okay? Then the shear flow comes here. Okay, the shear flow will go through all the way, okay? Then after it reach the terminal, the fastener again at the bottom, right? Then it will transmit the load of the shear stress, of the shear flow, okay? Then you'll go this way. So now, where do you take your first moment of area? Right? You only need this one. You can take this one, the one I shade in black, or you can take this one, the one I shade in green. Okay? And then the region of failure is just this region over here. Okay? So that's why constructing the shear flow is critical. That is why that's why for this case, the first moment of area is just that section over there. Are we clear? Interesting problem, yes or no? Okay, if we have not done those rules, what will happen? I have not a clue where to take my first moment of area. Okay, with that, I'm going to stop here. I'll see you again on Wednesday. Online, okay. What if we took Q as the middle? You can't, Jihan. Why you can't? Because it's not the terminal. Okay. You cannot. You have to start your analysis from the terminal. Okay, Jihan, that's the reason why you cannot take the middle. Okay, it's a white flange. Okay. Someone else put up your hand. Can you speak up?
So
Samuel.
Eugene, how come for the last question you took the middle as the terminal, but not for this question?
Samuel, I can't hear you. Can you speak louder?
I said, how come for the last question?
The last question.
Yeah, for your
I will do it next. I will do it on Wednesday. Okay.
No, like the previous question. The previous question, you took the middle as the analysis.
Yep.
Or for But for this question, you said you cannot take the middle as the analysis. Why?
You cannot what?
You cannot take the middle as for your first moment of area.
I did not say cannot. You can take the center as your first moment of area. I did not say cannot.
No, what I'm saying is, for the question we just did, why can't we not take the middle?
Samuel, hold on. I can't hear you properly. Hold on. Samuel, can I call you back in like 5 minutes time?
Yes.
Okay, I have to get out of class now. Okay.
Okay.